Refraction through a prism. Here prism is shown. This is prism angle. This is normal on face AB. This is normal on face AC. This is incident ray. This is angle of incidence. This is angle of refraction R1. The ray travels like this and it comes out like this. This is normal to, this is angle of emergence, and this is angle of refraction to or at this surface. And when we produce this ray, it goes like this, and when we produce this ray backward, it meets at this point. This is angle of deviation. Now we have to derive the relation between I, E, angle A and R1, R2. So let's see here in quadrilateral AQNS. Angle AQN is 90 degree. AQN equal to angle ASN equal to 90 degree. Now we apply angle sum property. So angle A plus angle N plus angle Q plus angle S equal to 360 degree. But angle Q and angle S are 90 degree each. So from where we get A plus angle N plus 90 plus 90 equal to 360, or angle A plus angle N equal to 180 degree. Now we consider triangle QSN. In a triangle QSN, R1 plus R2 plus angle N equal to 180 degree, and here we have got angle A plus angle N equal to 180 degree. So suppose this is equation number 1, this is equation number 2. So if we equate, we will get R1 plus R2 plus angle N is equal to angle A plus angle N, and that will give R1 plus R2 equal to angle A. Suppose this is equation number 3. Now we can apply exterior angle property here in angles X, Y, and delta. So delta will be equal to X plus Y, but I equal to X plus R1, I equal to X plus R1, and E equal to Y plus R2. If we find a sum I plus E, so we get X plus Y plus R1 plus R2. But X plus Y equal to delta, so we can say I plus E equal to delta plus R1 plus R2. And also we have R1 plus R2 equal to A. So from here we get I plus E equal to delta plus A. So this is our final relation. Now factors on which angle of deviation depends: the angle of incidence, the material of prism, the wavelength of light used, the angle of the prism. Now, minimum deviation and refractive index of prism. As we have seen, I plus E equal to A plus delta. For minimum deviation, I equal to E, and delta becomes delta F. Also, R1 equal to R2. So we have relation R1 plus R2 equal to A. From there we get, suppose R1 plus R2 equal to R. So 2R will be A, which will give R equal to A by 2. Also from here, since I equal to E, so we can write it 2E equal to A plus delta can be written as delta minimum deviation. So from here, so either 2E or 2I, so I equal to A plus delta M divided by 2. Now, refractive index mu is given by sine I divided by sine R. So sine I is A plus delta M divided by 2 divided by sine R, and R is A by 2. So this is a relation for finding refractive index of the prism. Now, deviation through a prism of small angle. So the relation that we have got is mu equal to sine A plus delta M divided by 2 divided by sine A by 2. If angle is small, in that case, we can do some approximation. So sine theta can be written as theta. So this will become mu equal to A plus delta M divided by 2 whole divided by A by 2. So 2 will cancel out. So we will get mu A equals A plus delta. So let's write delta M as delta. So from here we can get delta, and then mu A minus A, which implies delta equal to A times mu minus 1. Now let's see dispersion of light. The phenomena of splitting of white light into its constituent colors is called dispersion of light. This is prism, and this is white light. When it passes through it, it splits up into its constituent colors. They are memorized as Vibgyor that you have done in lower classes. So the least deviated color is red, and most deviated color is violet. Now, cause of dispersion. Oshie gave a relation which provides that mu is inversely proportional to second power of wavelength lambda square. And we have relation delta equal to A times mu minus 1. We know that red color has largest wavelength and violet color has least wavelength. So here refractive index of red from here, since lambda red is greater than lambda violet, so we can say mu red will be less than mu violet. So this implies, suppose we write for a red color, delta red equal to A times mu red minus 1, and for violet color we write delta V equal to A times mu violet minus 1. Clearly mu R is less than mu V, which gives delta red will be less than delta violet. Means deviation produced in a red color will be less than deviation produced in violet color. Now let's define two important terms. Dispersive media. The media that produce good dispersion of white light is called dispersive media. Example, glass, quartz, etc. Non-dispersive media. In vacuum, all colors of light travel with the same speed, and so the refractive index of vacuum is independent of wavelength, and hence there is no dispersion. Such a medium is called non-dispersive medium. Thank you for watching.